Just going to jump right into some content then. So for homework 3, we're going to cover how to do objectives 4 and 5 right now. And honestly, you probably could go through these instructions and build objectives 4 and 5 without a lecture. I would guess. I would think you'd be able to do that. But I want to give the background on why we're building this, why it's designed like this, and some of the structure here. So we're creating a RESTful API, or what I'll call mostly RESTful. It's not purely RESTful. We'll talk about that in the slides. Where we can create, retrieve, update, and delete data. And we're going to give users access to all these endpoints to be able to maintain data on the server in the database. This is a very common structure for an API these days. Maybe not this exact structure, of course, but any structure that looks like this, any structure that follows RESTful principles. And after today's lecture, you'll have all the content to be able to do all of the objectives for homework 3. On Wednesday, we're going to talk about testing APIs. We now have get, put, post, and delete HTTP request types. So how do we test those? That's what we'll talk about on Wednesday. I'm going to use something called Postman, show you how to use that and be able to send requests to the server to be able to test these more complex ones. We tested post before by having HTML forms and then filling out the forms and sending posts. We could just build a whole bunch of forms, but that gets gross quick, especially when you have a pretty complex API that you want to test. So we're going to use Postman, which lets us send requests without a front end. Postman is effectively the front end, and then we'll just send requests to the server. And when we use Postman, that's also how, if you want to look for security flaws, or if an attacker wants to look for security flaws, they'll use something like Postman to be able to send requests without using your front end at all. And then on Friday, we'll do examples. My intent is to do, actually, I'm not going to say my intent because I don't know exactly what I want to do. I have 2 big ideas, either examples of a better structure for the homework. I keep talking about that, a way to get rid of the else if, that big else if block. I either want to show an example of that or go through examples that are related to your project and give you examples of how you can set that up. I'm leaning towards the homework one, but I'll give examples of something interesting. If you have requests one way or another, or anything you want to see examples of, let me know. Nobody's really taking me up on any offers like that when I have demo lectures and ask for questions and stuff. But if you do, I'm still going to keep offering. If you do, anything you want to see on Friday, I'm open to suggestions for demos. Otherwise, I'm just going to do what I think you'll want to see, which might not be what you actually want to see. All right, anything before we get into it? Let's do this. Let's do it. All right, we're going to talk about APIs. Now, in general, we want to talk about how users are going to interact with our data. So this is the first time where we have a database. Just last week, we added databases to our app, and we have this persistent storage. We had some persistent storage, like saving images, but this is where we're getting truly persistent. I didn't have any persistent requirements in homeworks 1 and 2 specifically, so even those images didn't really have to persist. But now we do have persistent data, and by that I mean when the server restarts, that data is still there. So the database is going to outlive each instance of the app, each process of the app running, and then each time an app runs, or potentially you have multiple instances of your app all communicating with the same database, that database is going to persist. It's on disk. Nothing about the database is in RAM. It's all on your hard drive, so it will persist. So now that we have that, how are we going to let our users interact with this data? So even for objectives, objective 2, right? Yeah, objective 2, where we have the WebSocket chat. For objective 2, all we're doing, and 3, I guess, when we add the database, we're just storing the chat history. We're not giving users full control over that data. All they can do is post messages to the chat, and then the server handles how that's stored and how it's represented. The user can't modify anything. They can just send data to the server, and the server does everything else. What if we want our users to actually interact with the data? What if they want to update their profile or their settings? What if they want to make posts, edit those posts, delete those posts, What if they want to interact with things after they make them? What if they want to go shopping and they need a dynamic shopping cart that they can interact with? Data that's stored on the server, if the server crashes and their browser crashes and everything and they go back to the site, they should still have their shopping cart there. That should persist. And especially like their profile and stuff in the post. That should all persist, but the user has control over that data. So how are we going to do that? We have to have a way for users to interact with data that's going to be stored in our database that the user is going to control. That's what we want to talk about, and that's where we're going to use APIs. We're going to build a RESTful API to be able to have users do that. Specifically for the homework, it's them updating their email and username for their account. Just some basic enough just to have proof of concept that we could build a more complex API without exhausting you with a bunch of details, a bunch of tedious details on the homework. So we're going to build an API to be able to do that, so spoilers. But first, let's look at this in pieces. First, how is our database, how is our server going to communicate with the database? How are we going to get information into the database? Just how are we going to structure the way we interact with that? And for that, we're going to introduce CRUD. So CRUD is pretty standard out there, pretty industry standard of the operations that we need to be able to communicate, to be able to interact with data in a database. CRUD is an acronym for create, retrieve, update, delete, being the 4 operations for what we call I don't want to use that term, the 4 operations that we need to work with data. And if we have these 4 operations, we don't need any more operations. This is all we need. If we want to interact with data, we need to be able to create records, retrieve those records, update those records, and delete them. What else would you want to do with data? If there's anything else you want to do with data, it's probably going to be taken care of in the update. You're just going to update specific records to be able to change things around. Update's a pretty all-encompassing thing. Anything you want to do to modify a record that you're storing. So CRUD, and this is an acronym you're going to hear all the time out there in the working world, in the industry. Excuse me. Unless it's just so fundamental at this point that nobody says it. I think sometimes people don't say CRUD because what else would you do? It's like saying, oh yeah, we write code. Yeah, of course we write code. So let's go through these one at a time, and I'll just expand on each one of these, except update I don't have much to say about. And especially as it relates to the homework. So creates a new record. In SQL, this is our insert into. In Mongo, it's our insert. And we're going to always use prepared statements when we're dealing with SQL. Mongo, I don't know if I mentioned this or not, but Mongo doesn't really have there's no like Mongo injection vulnerability. There kind of is in some specific cases, but not really. It's something we just don't have to worry about. Mongo was built with that in mind, with this idea like, oh man, SQL has this vulnerability that every developer who works with SQL has to be aware of. So they built it without that. Hey, why not? It's pretty good. And the way it does it, just I'll keep this brief, but it won't treat this as the Mongo engine won't parse these as strings. It'll parse this just as a value. It'll treat this as a prepared statement. And it's the method that you're calling that actually has the logic. So we're inserting a record. We have these fields. That's all hard-coded. And then this won't be interpreted. This won't be parsed as a string just by default. These won't be parsed as strings as Mongo queries. Because we're in insert. If you have any Mongo commands in an insert, it's just going to be a string that's stored. It's not going to be parsed as Mongo. Is a Mongo query. When we create, it's very common and required for your homework, of course, that each record that's created is going to get a unique ID assigned to it. Now, the records, if you've worked with SQL before, you probably know about primary keys, that you need some identifying information in the record itself. Like for our example in the homework, I don't really have it on the slide. But for the example for the homework, email could be used as a primary key, and that can be used to uniquely identify a user. So why do we need an ID? So an ID is used to have some uniform way to access specific records of any type. So we have a specific standardized, specifically integer, way to identify a record, and we can write generic code that expects this ID to exist, that expects that ID to be an integer, and then we can access records through the same code of any different type. So we have users here, maybe we have posts and shopping carts like from the other slide, and we have all those different tables if we're using SQL. We don't want to have to hard code what the primary key is for each one of those tables. What type is the primary key? Maybe it's an integer, maybe it's a string, maybe it's a blob. We don't want to think about that. We have IDs, they're always integers, and we typically have them as auto-incrementing. We don't need these to be really convoluted or anything. There's no like security with an ID. These can be auto-incrementing starting at 1. And if you're using SQL, let MySQL handle this for you. Just say, just slap auto-increment on an ID field, and it'll create the IDs for you. So the very first record we create will have an ID of 1, the second one will have an ID of 2, then 3, et cetera, et cetera. Let the database do the work for you. If you're using Mongo, you have to do a little bit more work. Mongo doesn't have an auto-increment feature because Mongo doesn't have any structure at all. So you will have to build your own way to assign unique IDs if you're using Mongo. The standard solution, or I shouldn't say standard, but a solution in Mongo is to store in a different collection in your database the latest ID that was assigned. And then each time you create a new record, read that, add 1, and then assign that to the new record. So same thing that auto-increment does in SQL. We have to build that by ourselves in Mongo. One of the drawbacks, Mongo doesn't have any structure. It lets us do whatever we want. But that also means there's no structure to rely on. So we can't rely on anything that Mongo is going to assign. So this is required for your homework. Every time a record is created, every time a user account is created using the post request, assign it an ID, store it in the database with that ID, and then return the entire record, including the ID that record was assigned. Retrieve. This is grabbing a record. This is our select from. This is our find in Mongo. And for our purposes, for the homework and for RESTful APIs, we're going to grab records by their ID. So we have this unique ID. We know it's an integer. We know how to work with these IDs. So we're going to grab records by that specific ID. If we want the third record that was created, the record with ID 3, we're going to grab that record with ID 3 using either a where or a find. We can also do our just select star from table or find with an empty object, which is going to give us everything. So we can also say, give me everything from this table or this collection. Give me, or in general, every record of this type. This is often called list. Give me a list of all of the records that exist. So sometimes you'll hear this acronym CRUD. Technically, that's what we're doing with the assignment. We're building CRUD, but I don't know. I just think that sounds dumb. So I still just stick with CRUD. Even if I have list in the API, I'm still just going to call it a CRUD API because, I don't know, it's just the way I want to call it. I think CRUD is just, it doesn't roll off the tongue very, very nice. No other reason, but technically if somebody's like, technically your API is a CRUD API, you just know what they're saying and, use whatever term you're most comfortable with. If you want to stick with CRUD, fine. If you want to say CRUD and be correct, it's fine too. But just know that technically we're building a CRUD API. We have CRUD operations. And typically, in a lot of applications, the list request, that'll be restricted to like admin. You don't want to expose this to all your users. You don't want users being able to access every user account, for example. They should only be able to access their account with a standard retrieve. They should be able to just retrieve their account with their ID And then you have some server-side checks that say, is this your ID? If not, you don't have access to it. Update. This is our update. Well, I guess it's the same. Update in SQL, update in Mongo. And I don't have a whole lot to say about this one. You're going to specify a specific record by ID, and then update the information in that record. Modify the information. You can update all fields except the ID. The ID is constant. That's not part of the information of the record. That's just a way to identify the record. So you can't change the ID of a record. That wouldn't make sense to allow the user to do that, because then they're going to mess everything up. And in this case, the user is even our server. Don't even give us that permission. That's just asking for trouble. If somebody can update the ID, then we're relying on any dev who's updating the ID to enforce unique IDs, and that's just asking for trouble. So we can't update IDs for good reason. You shouldn't need to. IDs don't hold any meaning anyway. Technically, if they're auto-incrementing, they can be used to find the order of creation of records. So there's kind of some implicit meaning, but there's no like required meaning from that. It's just a unique identifier. So don't let anybody update them. Why would you want to update an ID? Just to break things. Deleting a record. Delete or delete. We're going to delete records by ID. Don't need any other information, no primary keys or anything. Just the ID for that record. We're going to delete by ID. That deletes the record. Now, in practice, for your homework, it's whatever. Just delete the records or however you can get it done, as long as the API has the required functionality. But in practice, it's pretty rare to actually delete something. Never actually going to delete information. Whenever we have information, we want to keep that forever. Any apps you use, they're probably doing this. They're probably never, ever, ever actually deleting anything. I think it's just, in my opinion, it's bad practice, and the industry pretty well agrees with this. Instead, we're going to do what's called a soft delete, where we don't delete anything, but we mark it as deleted. So once it's marked as deleted, no users can retrieve that information. If they request that information, they'll get a 404. If they try to update that information, they'll get record not found. It's effectively as though that record doesn't exist to the user, to any user, but it does still exist in the database. Just nobody can access that record anymore because you mark it as deleted. And then in your code you say, if marked as deleted, don't touch this record. Don't do anything with it. This is important to do. It allows a few things that we couldn't do otherwise. One, it preserves history. If you want to look back, maybe you have a bug and you want to go debug. Maybe there's a bug that was caused. Let me start that one over. Say you have a situation where there's a bug that was caused by a user deleting a record. How are you going to debug that? You have no information. You don't have the critical information that you need. You don't know that that record was deleted if you actually ripped it off of your hard drive and threw it in the garbage. You have no record that that record ever existed in your database. So how are you going to know what caused that bug? Maybe there's some specific information in that record that when it deleted, it just deleted in a really bad way that broke things. But if you're actually deleting that record, you have no way of knowing that. You're just guessing. And also, if a user opens a support ticket and says, hey, I deleted something, I really didn't mean to delete that. Is there anything you can do for me? And then you go, well, maybe there's something you can do. Then you go to the database and manually edit the database, which is always dangerous, very dangerous. But you could go in there and remove that deleted flag, and then they'll have that information again. So you don't actually delete it. And there are a plethora of other reasons. Maybe legal reasons. Somebody wants to delete illegal activity, and you would like to know about that. Anything you wouldn't necessarily want them doing. There could be, let me think of a better example. If maybe they're harassing one of your admins or something, and then they delete all their history, and now you'd like to take them to court for libel or something. And you can't do that anymore because there's no history of anything because they deleted everything. Don't actually let them delete it. Keep that evidence. and then you can take the appropriate actions after that. Wish I had a better example than that. But anyway, there are lots of reasons you would want to save that history. Any questions so far? I feel like the content of this lecture isn't, it's not crazy complex or anything. But if you do have questions, or if you want to dig deeper, if you have a question that, put me to the test and make me think instead of just go through each slide. If not, I can just go through them all. I mean, I have no problem with that either. Yes?
With the deletions in the database, you're just flagging it as deleted.
Mm-hmm.
You just update your queries to include anything that doesn't have that deleted.
Right. Yep. So like in our retrieve, like where we're retrieving everything, this would actually be select star from users where deleted equals false. And we actually usually store the deleted at timestamp. So we would say where that timestamp equals null. We would grab everything with that. If that timestamp exists, we're going to assume it's deleted. But we would put that in all of our queries. We make sure we're never retrieving data that has been deleted. Yeah, so in Mongo, right here in our, I do have it on this slide. Yeah, find, I would say find where deleted equals null or deleted equals false. Which will go right here. So Mongo, the query syntax is a little different. We're saying where, this is like saying where ID equals 3. So I would have where deleted equals false. And then just never retrieve that stuff out of the database. You could retrieve it and have code that filters. It gets a little dangerous though. Just don't even grab it from the database. Plus the database is going to be way more efficient in filtering. Yes?
I guess I was just trying to understand the user guide and use field. Because some cases might not necessarily have it.
The use for, what was that? I missed a little part of it.
The ID.
The ID?
Is it just because some cases might not have a username to search for?
It's to make things uniform. So like here we have user accounts, and then we'll have like posts which might not have a natural primary key with them, or image uploads, and they might have natural one we could pick out of there. We could say like the timestamp and user ID. Oh, that one's tough. But if we use IDs like this, we know that every record type has a unique ID and it's an integer. So we can write a lot of generic code that works with any record type, any table, any collection, and just works with IDs. And specifically like for the homework, we're putting these IDs right in our paths. So when somebody requests like a GET request for user/some ID, we can parse that ID as an int. We know it's going to be an int. So it's taking some of the pressure off of our parsers and off of our code there. We know it's going to be an int. Everything after that slash, parse it as an int, go to the database, get the value where that ID equals that int, and then retrieve that data. If we're using like email addresses or something different for each record type, it just puts a lot of pressure on our code. We got to think a lot more when we go to access our database, especially when we're doing it dynamically through HTTP paths. Anything else? All right. So that's how our server is going to interact with the database. We're going to use these CRUD operations, 4 basic operations, and that's how we interact with our data. Whether we're creating, retrieving, updating, deleting, those are the 4 things that we're going to do. And if you want to get technical, list as, I usually call it retrieve all or retrieve list, and slap it under the R. But list at the end to get all of the information. But how do users, that's only one side of this picture, so how do our users interact with our server? Of course, it's going to be HTTP. So let's talk about how we're going to design the HTTP side of our server. And we're going to use a few GET request types. a few HTTP methods that we haven't used before, this put and delete. And they're going to correlate with our CRUD operations. So get request is going to be a retrieve, post, create, put, update, delete, delete. So we saw get and post already. Get is when we're retrieving information from the server. Makes sense that that's going to be our retrieve method type. Post is when we're sending data to the server. And that's where I left post. That's where I left this conversation. It's when we want to send information to the server. Put is when we want to create or update a resource. Also, we're sending information to the server. And then delete is specifying a resource and saying delete this resource. And I guess more of a nuanced point, but in the world of databases, I'm calling them records, which would be either records in SQL or documents in MongoDB. And now I'm saying resources. Resources is the general term for the web, like a URI, Uniform Resource Identifier. We're always accessing resources over the web. So when we're in the world of the web, we're, pun unintended there, but when we're on the web side of things, I'm going to refer to them as resources. You request a specific resource with a specific URI. And based on the HTTP method, we're going to do something different with that resource. Either create a resource, retrieve a resource, update a resource, or delete a resource. We're always working with resources here. And this is abstracted, which is always a good thing. I shouldn't say always, but the user, from their perspective, they're just interacting with resources, and they don't care about the database. They just know that these resources persist. The user doesn't care if we're using SQL or Mongo or just straight up files on our, directly file IO. The user doesn't care. They're just accessing resources and interacting with resources. All right, so we got a few problems here. Post and put. I mentioned that both of these are made to send information to the server, and put is, I said, is used to create or update records. But what's the difference between these two? Why would we use one over the other? And the answer is kind of loose. So the methods, the HTTP methods, these request types, are mostly used to communicate between developers. And it's easy for developers to misuse these. So you might see something that's a put request that shouldn't be a put request because nothing's going to stop you from doing that. Just like nothing's going to stop you from sending a GET request with a body. You can do that. As long as your server is coded to parse bodies from GET requests. You can do that as long as your front end and back end agree. So it's a way to communicate to other developers and the people who are, the users who are consuming your API, to communicate what these endpoints do. If you say something is a put, there's very specific things that you're saying that path does, that request does. So specifically, a post is saying that the server might do some extra processing. The server is going to process this request based on the structure of this path. So you're going to send some information like a create request. You're going to say, here's my record, process this thing, and do whatever you do on this post request. There's something that the server has to do in this. For our purposes, that what the server is doing is creating the ID for that record. That's some extra processing that we didn't specify in the request. So that has to be a post request to create a record because the server is doing some processing. Creating the ID, that information just came out of nowhere from the user's perspective. Our server generated it with auto increment or whatever. But from the user's perspective, that ID came out of nowhere. That's something that the server generated, something the server processed. So our create has to be a post, or rather should be a post to be proper. Should be a post because it's processing. The other post requests that we saw in the semester, there's processing, storing, and then changing. You know what? I might have to think about that. Oh no, it generated the image file names. I was going to say maybe our posts could have been puts early in the semester. No, there was some processing. The image file names, whatever your naming convention was. Put is where the server does no processing. Put is just, here's some information, store this, and that's it. there can't be any extra processing, and a put request must be idempotent. Oh, what's idempotent? Let's talk about it. Idempotent means if you send the same exact request multiple times, they won't have any additional effect. If you send an update request, if you say update record 3 to have this email address and this username, the server is going to go to the database, find that record with that ID, and then update that email and username. If you send that exact request the second, third, fourth, fifth, 100th time, it's not going to have any additional effect. It's just going to still be that record. Whatever you sent as the username and email, it's going to be the same every single time. So you send multiple identical requests. Idempotent means that that's effectively the same exact thing as sending that request one single time. No additional effect on the server. And specifically, it doesn't change the state of the database on the server. Or rather, I could probably refine that a bit more and say it doesn't change the record, at least from the user's perspective. It's not going to change that record. You might do some logging or something on in a separate table and say this user sent this request at this time with this IP. You might store some logging like that. So it might change the state of the database. It's not going to change the state of that record that's being accessed. And there goes saying record again. That resource. It's not going to change the state of that resource. So get, pretty obviously, idempotent. In most cases, you can violate this. But get should be idempotent. Same get request should always serve the same information. You can write get requests that are not, but a true get request should be idempotent. And this is important for things like caching. A get request should always return the same thing. So then we're going to be able to cache things. Put and delete requests must be idempotent. I'd say this one you should be definitely strict about, because if you're not idempotent, if you're using put or delete and you're not idempotent, change that to a post request. So put and delete are idempotent. You can see in our design they're going to be idempotent. A couple of puts going to have the same effect as the first one. The first one already updated the record. You send an identical put request, it's not going to update the record again. Like mechanically it might, but it's updating it with the same exact values. Nothing changed. Delete, same thing. If you delete a record twice, it's not going to change the state of that resource a second time. Now, just because they're idempotent doesn't mean that you won't get different results. The responses might be different. The first time you delete, it might say deleted. The second time you delete, it might say 404. So you might get different responses, but we're not changing the state of that record. We're not changing, fundamentally changing like what's stored in the database or how the user is going to see that resource after that request was sent. Post is not idempotent. You send multiple identical post requests to our API for the homework. You're going to get multiple records created with different IDs. So post is doing some processing. It's not idempotent. So since that request, the creation request is not idempotent, we're going to make that a post request to communicate to consumers of our API that, hey, if you send a couple of post requests, identical post requests, you're going to get something. Like each one of those requests is going to be doing something different. In our case, creating multiple records with the same username, same email, but different IDs. You will get multiple records created. Let's talk about RESTful APIs. I've been dreading, I'll be honest, I've been dreading this part of the lecture for years. RESTful APIs are going to use, so REST doesn't have to use HTTP, but we're going to use HTTP because this is, we use HTTP with this. And this is going to give us a way to design APIs that are reliable and scalability. So you can have an API that's not RESTful. You can have an API that's RESTful. You can have an API that's that follows REST. The reason I've been dreading this is there's no like real concrete agreed upon definition of REST. There is no RFC for this, so there is no like this is the spec. Like everything else we've done in this semester, there's been here's the spec, here's like the order of bytes, here's what all the bytes mean, here's what semicolon means in this for this protocol. For REST, it's much looser. It's very loosely defined, maybe loosely understood. It's a bit more abstract. So with REST, I've asked, one of my favorite questions when I talk to anybody who does web development out in the industry, I'll ask them, what is a RESTful API? And I get a different answer every single time. So because there is an actual like definition of REST, what something is that's RESTful. I'm going to blank on the name, but it was someone's dissertation who defined, coined the term and said, if something's RESTful, it must have these properties. But out there in industry, the consensus, I feel like, has gotten away from that a little bit. So there is some overlap with all the answers that I get. And some of those answers with that overlap are disjoint from what that dissertation actually says. So just keep this in mind that the term RESTful out there in the world, out there in this industry, means a lot of different things to a lot of different people. And we typically use this as kind of an adjective. Like an API can be more or less RESTful, and we use it as a spectrum. Like if like two developers will have a conversation where one's like, I want to add this endpoint to our API. The other one will say, I don't know, I don't think that's very RESTful. That's kind of how the verbiage is used out there in the industry. And I'll say that the homework API is mostly RESTful. We don't follow all of the RESTful principles, but it's pretty RESTful. But I don't know. It depends whose definition of RESTful you're going off of. It's mostly RESTful if you're going off the actual definition. Out there in the industry, I think some people would be tempted to call it fully RESTful. Oh, that's a RESTful API. But anyway, let's go through the REST constraints. You can read up the dissertation. I should have linked it actually. But I'll go through the constraints that make something RESTful according to this kind of loose definition. It should follow a client-server architecture and be stateless. I'm lumping these two together because we get both of these with HTTP. We're using HTTP, it's a client-server architecture, and it's stateless. So check mark on that. We got that. Now we can violate this. There are always ways to break things and make things not RESTful. If we're relying on cookies in our API, we just violated statelessness, and we're less RESTful if we were relying on cookies. Honestly, I don't know a good reason why you would rely on cookies for a RESTful API. Actually, no, I do know one. For authentication. So once you have authentication, you're by definition not RESTful anymore. So that's one of them things that kind of gets a little wonky. Like, we like authentication. With authentication, we're technically not a RESTful API. So do we care about that? So you can have something with authentication out there in industry. We're still going to call that a RESTful API. So this is where things already get a bit muddy. Other than authentication, why would you be using cookies in your RESTful API? As I say that, well, rate limiting. I would say rate limiting also would be a good answer. There are reasons. But once you do, technically not RESTful, but is anybody going to get mad at you? I think the person saying, well, technically, we need to remove all authentication because then we're not RESTful. Adhering to a definition that strongly, I'd say, is a very big negative. A developer who probably should lose their job. Cacheability, each response, this is one part where we're not RESTful in the homework assignment. This is something I want to add to the course eventually, not get into it this semester, all the, everything around caching. But cacheability, every response should specify any caching information. One, is it cacheable? Is it not cacheable? If it's cacheable, any timestamps, any information related to caching needs to specify everything about caching. And anything that can be cached should be cached. Anything that can't be cached and any stale data should not be cached. So making sure that everything's still up to date, but caching whenever possible is a good RESTful API. Very good for scalability and performance. Should be a layered system. meaning that if the user isn't communicating directly with your API, it's perfectly okay. So we should be able to add layers of abstraction between the user and the client. Few reasons we might want to do this. We might want to have multiple instances of our API running and have a load balancer that the client communicates with. So the client sends a request to a load balancer. The load balancer finds out which instance of our app on which machine, thinking a distributed system, which instance of our app isn't completely bogged down, send the request there, and then also have a distributed database that they're all communicating to. We want to be able to scale up like that. So if we don't have a layered system and every client has to communicate directly with our single instance of an API, we're not going to be able to scale up to millions of users. Probably won't even be able to scale up to like hundreds of thousands of users at that point. If we want to scale up, we have to be able to have a layered system. And also, a really nice thing is if we want a proxy or reverse proxy server that adds encryption, this is something I always like to do. I don't write apps that speak HTTPS, like ever. I just don't do it. What I do is add a layer in front of my server that's going to speak HTTPS to the outside world. It's going to get HTTPS requests, remove the S, and send the unencrypted request to my server, which is running on the same machine, so nobody's going to intercept that traffic. If we're using a layered system, we can do this pretty easily. We just add Nginx or Apache or some server in front of our app, which is going to communicate to the users directly and then send requests to our app. If we're embracing a layered system, there should be no problem. Which our HTTP servers are kind of inherently layered systems. I'm blanking on an example of a non-layered system that's also a web app, but sure there's an example out there that exists. And uniform interfaces, there's a lot in this one. The resources are defined in the requests for our homework purposes. This is putting the ID in each path. So the path, the request itself, is identifying each resource. Whenever the user has a record, they have enough information to be able to work with that record, either update or delete it. Specifically for our purposes, they have the ID. So even when you get a create request, the spec of the homework says for that create request, you have to return the entire record, including the ID in the response. Part of that is to satisfy the second condition, that whenever the user is holding a record, they should have all the information they need. The biggest piece of information is that ID, so they can uniquely identify that resource. So even on the post that creates a record, return the whole record with the ID, so the user has all the information they need to be able to work with this record. If they create a record, and then the response has no way of identifying that record, it really limits what the user can do with that record. They have to somehow send a GET request to try to get the list and then try to find their record. And then if somebody has an identical email or username, which we should have logic to prevent. But if they do, we're not going to be able to uniquely identify the record we just created. It's a mess. So respond with the ID in all of the requests. When you update, the only exception is when you delete, because that record doesn't exist anymore. We don't respond with anything. Oops, I blanked for a moment there. Every request should be completely self-contained. So every put, delete, post and get are kind of self-explanatory, but every put and delete has all the information needed to handle that request. We don't need any extra information from anywhere else. The HTTP self it alone is enough information to know exactly what to do. For a put, we have the ID in the path, and the body is the entire record that needs to be updated. So we have all of the information we need. And the API should be self-contained. This is another one we're violating in the homework. So there should be like a home path to the API, which returns links to all of the paths that can be used. Basically, effectively the documentation for that API. We should have one path where you request it and it returns, I support get with this format, I support post with this format, I support put with this format, I support delete with this format, and this is what they all do. You should have all that documentation contained in the API itself. We don't have this, we violate this because a lot of this is defined in the homework document. There's a separate documentation that we need separate from your final API that you need to be able to know what the API does. So another violation, cacheability and the API is self-contained. Those are the two things where I have to say, oh, it's mostly RESTful. It's RESTful enough for our purposes. But just so you know, those are a few from the document that or from the dissertation we are violating. Oh, I have a duplicate slide. And that's how our users are going to interact with our data. They're going to use a RESTful API to communicate with our server, and our server is going to use CRUD operations to communicate with the database to be able to access it, update, create, retrieve, update, delete information. The RESTful API, pretty much, well, in our purposes, is a one-to-one correlation between the CRUD and technically CRUDL operations on the database. And that way the user can have effectively direct, I mean not literally direct, but effectively directed control over the data. They can execute those CRUDL operations through HTTP requests via our API. All right, any questions? That's my last slide. Any questions? How does the server know what ID is used in updates? So the update is going to be part of the, like when we send an update, we're going to send the ID in the path of the URL. And then the database is going to, the server is going to go to the database and look up that ID. If a record with that ID exists, update it with the body of this request. And if it doesn't exist, give them the 404. Just say, hey, I don't know of a record with that ID. Hit them with the 404 and say, try again. No, but it'll be right in the path. I think, assuming I understood that question right. So the database is remembering because, or the server is remembering because it'll store that in the database. It'll ask the database each time, hey, do I have a record of this ID? If so, let's update it. If not, 404. All right. Have a great day, everyone. See you Wednesday.